Permutations and combinations. So your first unit exam will be on perms and coms and transformations. So it's a whole lesson on transforming all the functions that are out in the world. So last year you guys looked at quadratics, a little bit at reciprocals, and a little bit at absolutes. This year we're going to look at radicals, rationals, other functions, adding, subtracting, multiplying, dividing functions. We're going to look at polynomials up to degree 5. We're going to look at exponential functions, log functions, trig functions, like what trig graphs look like, and any function, anything that passes the vertical line test, we can move. I know, so fun, right? Yeah, your face says it all, like excitement, Jackson, excitement. He didn't look scared at all or annoyed or tired. You would have normally just woke up. Maybe that's what it is. Yeah. All right. This first unit is, I'll say, wacky. Okay? You're going to be like, where does this fit in math? Well, we'll do math to get answers, but majority of it is words. Like, we're going to find out how many ways 5 people could sit in a movie theater, and then how many ways could 5 people sit in a movie theater if Joe and Frank got in a fight and don't want to sit next to each other. That's what we're going to do. And then we're going to find out, like, how many different ways can you rearrange Mississippi? Because everyone cares about that. Or, like, Mississippi starting with a vowel. Yeah. Thought it could get more fun? Well, we're also going to figure out, for example, like, how many card hands contain at most 3 queens. Or something like that. Yeah. Sure. Perfect. All right. So, it's going to be the best. Get ready. Okay? For, like, a ride. Real good. Okay. So, permutations order matters, combinations order doesn't matter, and currently you've learned neither of them, so this makes no sense to you. It's totally fine. But I'm going to give you examples of what permutations are, and when we're done learning both of them, we'll come back and revamp this, because the problem with me when I was in grade 12 is I didn't know the difference at the end of the unit. If you don't know the difference, you're 50-50 guessing all the time, which results in poor marks. This was a bad unit for me, and I was like, I don't like it, so I don't care. That's kind of how I was. I don't want that to be you. I want you to be like, I know how to do this. This is easy. Okay? So because I despised it, I try and make everyone understand this here. Okay? Now, places where order matters is like a license plate. If you have the same license plate, if yours is like BBF 079, and it was, instead of BBF, it was BFB 079, that's a different license plate, correct? Like if someone just robbed a bank with BBF and I have BFB, I hope they know those are different, right? PIN numbers, like when you go to your door and you put in your 4 digits to get into your door or to get into your bank card or whatever it may be. They have to be in the correct order, yes? So order matters there. Words order matters because if not, pool and loop would be the same word and they're not, right? So the way that the order that you put your letters in matters. So that's permutations and combinations. And we'll talk more about that when we actually get to that. We're going to talk about the fundamental counting principle today. This paragraph that I read is going to sound overwhelming. It's not overwhelming. It's just broad, which makes it overwhelming. Then we're going to actually do math to make it make sense. Okay, so don't be overwhelmed by its words. So here it says, consider a task made up of several stages. If the number of choices for the first stage is A, the number of choices for the second stage is B, the number of choices for the third stage is C, etc., then the number of ways in which you can complete the task would be A times B times C times however many, and that's the fundamental counting principle. Well, it sounds overwhelming, but we're going to go through an example so it doesn't sound overwhelming. So first example is a toy manufacturer makes a wooden toy in 3 parts. So there's just this toy. There's a part 1 on it, a part 2 on it, a part 3 on it. You need 1 of each part. They put them together, you get a toy. Okay? Part 1. The top part of the toy, let's pretend it's a robot. You have the top, the middle, and the feet of the robot, okay? The top part can be red, white, blue, or pink. The middle part can be orange, purple, or black, and the bottom can be yellow or green. And we're going to use a tree diagram first to determine how many different colored toys that can be produced. The tree diagram is just so that, oops, I need a marker. It's just so that you can see the amount of outcomes and that you believe when we use the fundamental counting principle, you believe me because we get the same number. It also makes the fundamental counting principle to make sense. So let's do a tree diagram. Now by tree diagram, I mean like anti-gravity horizontal shrub is what we're going to draw. If it looks like a tree, you're wrong. So not sure why they called it tree diagram, but they did. You should call it anti-gravity, horizontal shrub, or tree, or whatever. Okay? Follow along. So, part 1 is what we're going to start with, and I'm going to write part 1 at the top. Now, I'm going to write these 4 letters, red, white, blue, or pink, as options below, and I'm going to leave spaces between them, because off of each of them I'm going to have branches. If I stack them right on top of each other, I will not have space for branches. Someone will not listen to me and stack them anyways, and you have to erase them, but that is on you. Okay, so we're going to have red, space, and then we're going to have white, blue, pink. Yes? If this toy only had part 1, how many different toys could I make? 4. Yes, this is not rocket science. Yes, I can make 4. It would be a red toy, a white toy, a blue toy, or a pink toy. We agree? But it doesn't have 1 part, it has 3. So let's talk about part 2. Part 2, the middle part, has orange, purple, or black. Okay? So, off of the red, I'm going to have orange. And I need to have spaces because these are going to have more off it. Purple, black. And then off the white, I'm going to have orange, purple, or black. And off blue, I'm going to have orange, purple, or black. I think I'm going to have orange, purple, or black. So if I had 2 parts to this toy only, I could have a red-orange toy, red, purple, red, black, white-orange, white, purple, white, black, blue-orange, blue, purple, blue, black, pink-orange, pink, purple, pink, black. So how many toys could I have? How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We agree? So I would have 12. Problem is, I don't have 2 parts. This toy has how many? 3. So we have part 3, and part 3 has 2 options each, yellow or green. I'm going to be lazy, so I'm just going to go Y and G. This little blue box decided to join us. So now instead of 12 toys, how many would I have? 24. All you did was what? Double it. You times by 2 because there was 2 more options, right? So each of those 12 options now has 2 more options, which makes it be 24. Do you agree? You could use a tree diagram to show options all the time, but this would be ridiculous when your answer is 65,500. Like you can't, right? In 30-2, we do this as well, and tree diagrams come up because they have to do probability. So if I said, what's the probability of having a toy with a red in it? Well, then you would have 6 out of 24, a quarter. So you can visualize it, right? It'd be a lot more easy to visualize. So you're not usually asked to find tree diagrams or anything like that, but it's a way to show that the fundamental counting principle works. So the fundamental counting principle says if I have more than 1 part, and I have to use each one, then I could technically multiply the options together. Well, how does that work? Well, here I have part 1, part 2, part 3. I can only use the fundamental counting principle if I'm choosing one of each. So if from part 1 I could pick 2 colors instead of just one, I couldn't use this. I would have to do a different method. Okay? So I can use fundamental counting principle because I need one color. So this represents one color from part 1, one color from part 2, one color from part 3. Okay? Now, do I need part 1 and part 2 and part 3, or do I need part 1 or part 2 or part 3? And or. To make the full toy. And. So because I'm using the word and, I'm going to write this over here. Whenever I use the word and, I multiply. And if I use the word or, I add. And the way I remember this is and add look like they should go together because they're basically the same word. But they're so similar they hate each other. They do not. So if I have and, I multiply. If I use or, I add. So I need part 1 and part 2 and part 3. So I'm going to multiply. Now what I need to know is, I'm taking 1, so that's why I get the blanks. Now what you do is you don't list what outcome you pick above, because I have 4 outcomes I could pick for the first blank. What goes above those blanks in the fundamental counting principle is how many options you have. So how many options do I have for part 1? 4. How many options do I have for part 2? 3, and I'm picking 1. That's what this blank is for, right? How many options in part 3? 2, and I'm picking 1, right? What's 4 times 3 times 2? 24 different toys, same answer. And it makes sense because the first answer was if I had only one part, I'd have 4. If I had 2 parts, I'd have 12 because that's 4 times 3, correct? Times 2. So as you add parts, you just multiply by the options. But you can only be choosing 1 from each part. Like I said, if I could pick 2 colors from one of the parts, it'd be done. I would not be able to do this. I have to do a different way, which you don't know how to do right. Next page. So, this one, I have a school cafeteria, offers sandwiches made with fillings of ham, salami, cheese, or egg on white, whole wheat, or rye bread. Okay? So this sandwich has 2 parts. It's the weirdest, crafty sandwich, unless you just like meat and bread. Then this is a great sandwich. But it has 2 parts. It has a filling part and a bread part, right? Sandwiches often have more options, but this one only has 2. Now, I know I can use the fundamental counting principle if I'm picking 1 filling and 1 type of bread. If I was allowed to pick 2 of those fillings, I can't use the blanks. I can't use fundamental counting principle. So let's keep reading. How many different sandwiches can be made using only 1 filling and means I multiply 1 piece of bread, 1 type of bread, not 1 piece. Okay? So I'm choosing 1 of each, so I'm allowed to use fundamental counting principle. This is the filling, and means I multiply. This is the bread. How many fillings? 4. So I'm choosing 1 filling, that's what this blank means, 1 filling out of 4. And 1 type of bread out of how many? 3. So what does this equal? 12. Do you see how I have an equal sign? I know it's crazy. It's crazy because people don't use them. That's what's crazy. So when you're doing math, remember that if it's written response, which you have written response, you have 24 multiple choice, 8 numeric, and 3 written. Each of the 3 written has 2 parts. You have to show all your work because if it's not perfection, you're going to lose at least 0.5 off that question. So we always work for perfection. So if I went 4.3 and then 12, am I explaining anything if I go 4.3? What they would read is 4.3, 12. And people are saying, they'll say to me, well, it's teachers marking it. They can figure out that 12. Like, that's on that. You have to pretend that the person marking it is dumb. Literally, like, they look at them and be like, 4.312, what is this child doing? If they have to do work and they get the mark and you don't, right? Like, if I, as a teacher marking it, have to, like, figure out, oh, they multiplied it and it equals 12. I get that piece of the mark and you don't, because I did the work for it and you didn't. Do you see what I'm saying? So just show all your work. We're going to do proper work, because what I want is, I want you to write a final, a diploma, and you not to lose marks. Okay? Because that's my goal. I don't want you losing 0.5s all over the place. That adds up. So we have 12, and then because it's a question, it says how many different sandwiches can be made? 12 different sandwiches can be made. Let's look at the next one. It says a Math 30 quiz consists of 8 multiple choice questions. So how many parts are there to this test? 8. Question 1, question 2, question 3. Now when you do this 8 multiple choice question test, do you have to do question 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8? Or do you have to do 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8? Is it and or? And. Everyone wishes it was or. You didn't know how to do it, you didn't have to do it. Wouldn't that be great? That would be or. So, we have question number 1, and multiply. Number 2, and number 3, and number 4, and number 5, and number 6, and number 7, and number 8. Now, the reason why we can use the blanks is we pick one answer, right? You don't get to like pick numerous answers on multiple choice. Yeah? You pick one answer out of how many options for this question? 4, because you have A, B, C, and D, right? So number 1, I pick one answer out of 4. 2, I pick one answer out of 4. 3, I pick one answer out of 4. Same thing, same thing, same thing. And it wants to know how many different sets of answers are possible. So that means different answer keys. So a lot of people tell me this is 4 times 8. It's not 4 times 8. It's 4 to the power of 8. $65,536. Is that what it is? I do not have this memorized. I did this question in period 1. I believe that is the answer. Is that the answer? 65,536? Is that what it is? Okay. All right. So, when people write 8-question quiz, or in chemistry you have a 5-question multiple choice or whatever, those daily quizzes, and you're like, oh, this can't be hard to get a really good mark on it, even if I don't study it. Like, a chance of me getting 100 or close is pretty good. An 8-question multiple choice test, A to D, answers, has 65,536 different answer keys. So if you don't study, you have a 1 in 65,536 chance of getting them all right. That's why studying is so important. Because that is a lot of answer keys, right? You don't think about it, but like they can all be A, and they could one be A and then all be B, one be A, all be C, one be A, all be D. Like there's 65,000 different answer keys. So, what if I give you a little bit of a change? So I have it, Mrs. Lepp has an answer sheet, answer key on her desk. If I did this, you guys would all cry because you think you did something wrong. All right. That's my answer key, yeah? And then I'm just so clumsy that I spilt my coffee and it wiped out the first 5 answers. Okay? How many different answer keys could I have now? And the answer is not 65,536. Try to discuss it. See if you can figure out the difference. We could show this in two separate ways, right? You could say, well, 6, 7, and 8 aren't changing, so I'm ignoring them. They're going to give me one answer. Or you could involve them. So this would be question 1, 1. Nope, that's an eraser. 1, 2, 3, 4, 5, 6, 7, 8. You could involve all of them if you wanted to. But this would have one option, one option, one option. We agree? Because they can't change. They're there. They're DDD. What would be the options for these ones? How many each? 4. So this would equal 4 to the power of? 5. What's that? Yeah. If this is a written response and you just write 4 to the 5 equals 1024, remember on a diploma, your written response, you have 3 questions. I'm just laying this out for you. Each question is out of 5 marks total. 1 part is out of 2 and 1 part is out of 3. Okay? If this was all you had on your page and the question was out of 2, do you think they could give you 2 marks for that work? Because they're going to say determine. The moment they use the word determine, which I'm going to give you guys a formula sheet after this, it's bright pink. If they use the word determine, that means you have to show work. You have to show what you did, and 4 to the 5 is not showing what you did. So determine, the actual wording, it says, find a solution to a specified degree of accuracy to a problem by showing appropriate formulas, procedures, and or calculations. You have to show work. So you could have shown the blanks of the fundamental counting principle, and then that would be actual work showing what you're doing. You know what I mean? If it says state, that's different. When it says state the answer, state is just an answer. State's fine. State is not determined. So those questions on the diploma have to be bolded. Those words on any of these. Ooh, let's do this. This is science and math directing words given to you by the government. If any of these are on there, and I justify these a lot, which people really love. They really love justify and they really love explain. Because who doesn't want to justify or explain in math? Everyone. No one wants to do that. But so you cheer a little bit. But one of them is usually on the diploma. One of those words. If they're on, they have to be bolded. And they come from here. Okay? So for your test, you're going to have the formula sheet. And it's on that side. It looks like this. It will never change. The government gave it to me. I'm giving it to you. Okay? That's what you will get. So if people are like, is this on the formula sheet? I'll say, is it on the formula sheet? And you'll say yes or no. And if you say yes, it is. And if you say no, it's not. Because I have no control over this. Okay? The directing words I will leave on the back for you for the test. But on the diploma, these don't exist. They don't give you like what they mean. They'll bold the word so you know it's from this list of terms. By the time the diploma comes, you know what these mean because we practiced them. Okay? Plus, you've seen them before in 10 and 11. Your teachers use these. All right? Okay. So what I'm going to have you do, because I'm being kind today, can you flip ahead to page 3? Embedded in your notes are the questions for homework. This one you could title Fundamental Accounting Principle as your homework. I'm just having you do numbers 1 to 3 today.